All right, our next section and our last section, and it's also going to be probably the most difficult section of this chapter, is our discussion of radioactive elements. So we're going to start off with a quick review from last chapter. You're going to want to think about protons here. So what makes carbon carbon? Again, it's the number of protons. Carbon has 6 protons. If you decide to give carbon another proton, it is no longer carbon, it becomes nitrogen. If you want to take a proton away from carbon, it is no longer carbon, it becomes boron. So carbon is defined by its number of protons. When we get into radioactive decay, we're going to be changing the number of protons in our atoms, and therefore we're going to be changing our atoms. So think about chemical reactions. Pretty much up until this point, any reaction that we saw was a chemical reaction. Those involve electrons. If you recall from last chapter, elements would lose, share, or gain different electrons in order to form bonds. Here we're going to be talking about nuclear reactions. That involves the nucleus of your atom, and therefore we are going to be changing the number of protons and neutrons in our atom. And it's not as done as simply as chemical bonding. So you don't see a lot of this naturally occurring all the time, but it does happen, and it does release or require a lot of energy to do so. So let's first talk about radioactivity. Radioactive decay or radioactivity is what we're going to refer it as. This is when our atomic nucleus, so the nucleus of our atom, is so unstable that it is just going to start falling apart. It's going to release a fast-moving particle, and in doing so is also going to release a lot of energy with that. So there are different types of radioactive decay or radioactivity, but all of them are going to revolve around the release of a particle and energy from an unstable nucleus. Our hero of radioactivity is a man named Henry Barkwell, and just like many scientists, he accidentally discovered this. He was studying a mineral that contained uranium, and it developed photofilm. So this is his accident right here. He took this material that had uranium in it, and he noticed that sunlight gave off energy. I mean, it would be like kind of glowy in the sunlight. And this material would be able to develop photofilm just like the sunlight was able to develop photofilm. So what he did was he decided to take this material, and he accidentally stored it where his film was, and he noticed in the morning his film was exposed even though there was no sunlight. He's like, think about putting it in a desk drawer where the sun doesn't reach it. Uranium was able to develop the photofilm and expose it, and therefore ruin his photos. But in doing so, he discovered that, well, sunlight didn't expose my film, so something had to be done with this mineral that was in this rock that he was looking at, and therefore he decided that uranium was the culprit here, and it was able to expose film. So it was giving off some kind of light energy. Even though he couldn't see that light energy, it was still being given off, and the film was picking up on it, and it developed. So radiation, again, is just going to be light energy. In most cases, we're going to think of radiation as light. So when we give off our radiation, we're giving off a form of light. And therefore, his photofilm was able to develop. And it happened spontaneously. It didn't happen like all at once or anything. It just happened spontaneously over time. And we call this radiation radioactivity. So you can think of the sun giving off all of its light, and that light is what we're going to refer to as our radioactivity. Radioactive elements were then further discovered and tested. You probably have heard of a scientist by the name of Marie Curie. who was the first woman to win the Nobel Prize, and she did her research on radioactivity and radioactive elements. For the majority of our radioactive elements, we do need unstable nuclei, and you get unstable nuclei in your very heavy elements. So here's a couple Bohr diagrams of polonium and radium right here. Uranium is even heavier than these two, so you can think these are fairly complex elements as of right now, which means there's more that can go wrong with them and become even more unstable.